Thank you for tuning in this evening. We are on K-Praise 1210 a.m. down here in Southern California. We're broadcasting locally. We're also up in North County. And then, of course, we're all over social media. We're on podcasts, and so you can find us everywhere. And we've had some great shows recently. And this evening, we have a very interesting show. Spike Psarris, he has a bachelor's in science and electrical engineering. Bachelor's of Science in Electrical Engineering from the University of Massachusetts. He's done graduate work in physics, and he was formerly an engineer in the United States military space program. And he's going to be talking to us this evening about the planets and how these point to God, a biblical worldview of things, a creationist worldview, not to an evolutionary worldview or an atheistic Big Bang. So, Spike, thanks so much for being on the program today.
Yeah, thanks for having me.
Absolutely. Well, I teach 12th graders, and we talk about this. We talk about the Big Bang and these sorts of things. And I've got quite a few questions that I'm really curious about. But you also have 3 DVDs that you're selling on your website, creationastronomy.com. And I like the title. It says, "What You Aren't Told About Astronomy." And that's really the subtitle there that you put. Can you explain that a little bit? What is there really a lot that people don't know about astronomy that's not out in the public that is actually factually, evidentially, demonstrable?
Well, I think so. There's a real disconnect, in my opinion, between science that's presented to the public versus the science that's actually being done. If you read the papers in the scientific journals and you follow the research that's being done, often the conclusions that are presented to the public as being quote unquote known or facts aren't actually that well supported. In addition, there's a lot of evidence against some of these mainstream views that also typically doesn't filter down to the public. And by the public, I mean, science museums, planetarium shows, textbooks, science programs, all those sorts of things. The typical channels through which people get scientific information often do not contain a lot of this other material that really calls into question a lot of the conclusions that are being drawn.
Are we talking about in, like, for example, like a high school science classroom or a college, a university level science class, or are you talking about, out in the public beyond school?
Both, actually.
Okay. Interesting. So give us some examples of that. What are some of the glaring examples that you're talking about that people have a particular perspective that really there's a lot of contradictory evidence to?
Okay, the origin of our moon would be a good example of this. So if you go look online or any of those other education outlets that we just talked about, you'll hear about something called the giant impact theory, which is the idea that our moon originated from a giant collision between the Earth and a very large, like Mars-sized object early in the Earth's history. So supposedly this object came in, hit the Earth, blew it up into a bunch of material. Most of this material fell back down. Some of it started to orbit the Earth, though, and coalesced into what we have today as the moon. Now, this is presented pretty much universally as the model that we know this is how it happened. But yet there's actually a lot of evidence against this model that shows it can't have happened that way. The model itself, even from the beginning, was understood to be very contrived, first of all. You need to have an impactor come in at exactly the right speed and angle and the right mass and all the rest of it. So it's already kind of veering into special pleading as to how finely tuned this supposedly random event had to be. But over the years, more and more evidence has accumulated against this idea. For example, the Apollo astronauts back in the late 60s and early 70s gathered a lot of samples from the moon's surface and brought it back to Earth. There was actually several hundred pounds of samples that they brought. And it was that material was analyzed at the time to the best of the laboratory equipment that we had, which was well done. But of course, several decades later, we have better equipment now. So some people decided to go back and re-examine that material to see if there's anything that was missed. And it was discovered that some of the soil samples that came back from the moon's surface had beads of volcanic glass in it. And inside the volcanic glass, there was water. Now, not much water, it's only trace amounts, which is why it was missed in the 70s. But that's interesting because water on the moon's surface doesn't necessarily tell us much about origins. That could have come from comets or meteorites or whatever after the moon formed. But volcanic glass from inside the moon, if that contains water, that means there's water in the moon's interior. Wow. That tells us that the material that the moon was formed from also contained water. And had a giant impact occurred, that would have vaporized whatever water was present at the time And the moon could contain no water today if it were the result of such an impact. Now, this was first published in 2008. Subsequent people have gone back and looked further, and it turns out there's even more water in the moon than was originally thought back then. Now they estimate that if all the water in the moon's interior was brought up to the surface, there'd be a global ocean about a meter or so deep.
Oh my gosh.
So
wow,
there's incredible. A lot of water. I mean, the moon is still a dry object, don't get me wrong, but it can contain no water at all if that impact story was true. The presence of water discredits the impact story. Yet the impact story is still being taught and presented as if it's known fact, despite this and other problems that have arisen with it subsequently.
Oh, that's a big one. Yeah, because I mean, that's everybody's heard about that, that this is where the moon came from. And you said it was contrived. When you say it's contrived, are you meaning that there's not really any evidence to support the view? It's just really, really hypothetical, or what do you say? What do you mean when you say
the evidence that we have is that there's an Earth and a moon.
Yeah, exactly. Okay. So it's just assertion then.
It's just, whoops, those are my earpieces here. The assertion is, I mean, it's computer simulations. So this raises kind of philosophical questions about, is a computer simulation really a scientific model? I mean, ultimately, a simulation, at best, it tells you one way something might have happened. It doesn't tell you that it actually did happen that way, because you can construct a lot of simulations on a lot of different stories that all fit there being an Earth and a moon today.
Gotcha. Now you are a biblical creationist. You believe in what the Bible says about the 6 days of creation, right?
Correct.
Now, is this a position that you've held for a long amount of time? Was there a point that you were not committed to that perspective, or is that something that you've always held?
In another birthday or two, I'll reach the point where it'll be half of my life.
Okay.
It's still more than half my life to this point. I was coming at this from the opposite perspective.
Oh, wow. Okay.
I was an atheist and an evolutionist.
Oh, okay. Huh. So what changed your mind?
Well, a coworker, while working in the space program, I got to talking to him one day over lunch about origins, and I found out that he was not only a Christian, but also a creationist. And I was kind of dumbfounded because I was well-versed I was an atheist because I was an evolutionist, basically. I understood that science showed there was no need for a creator. So why believe in one? Science shows that there's no justification for that. So when I found out he was a biblical creationist, I was kind of taken aback because he's an intelligent person. He's there working with the rest of us.
Yeah.
So I was trying to make sense of this. And I said, well, how do you reconcile that with all the obvious evidence for evolution? And he said, what obvious evidence is that? So I started to talk about radiometric dating and the fossil record and all the rest of it. And he started to debunk all of my assertions. He's well-versed in apologetics. He's a good friend now.
Okay.
He was aware of the arguments I was going to make, and he had answers for them, for most of them already. And the ones he didn't have, immediately he went and found. And as I went and checked his answers, it turns out he was correct. And he was very gracious about it. I mean, I'd say, what about this fossil sequence? And he'd say, they threw that one out about 3 years ago. You should go look at that. So I go look at it. Sure enough, they threw that one out 3 years ago. So I asked him a lot of questions, and he kept answering. And I didn't agree with him necessarily, but I at least saw that he had a coherent worldview. It wasn't just blind faith in the Bible, which is my view of creationism at the time. Eventually, over weeks and months, I ran out of stuff to ask. And so he turned the tables on me. He said, okay, I've answered all your questions. Now you can answer mine. So that's fair. He said, you believe in the laws of physics, don't you? I said, well, yeah, we use them here every day. He said, how do you reconcile those with the Big Bang model? And he didn't even explain what he meant. So I thought about the question and I realized, wait a minute, Big Bang model and some very fundamental physics don't play well together. Actually, they don't play at all. You can't, now I realize I'm believing mutually incompatible things at the same time, apparently.
So give us an example of what you're talking about there for the average person here. What is it about physics and the Big Bang model that don't do well together?
I've since boiled this down into something I call the secular dilemma. And this wasn't quite how it was presented to me then. This is just a result of my thinking since. Mm-hmm. If you're going to construct a cosmogony, a history of the cosmos, an explanation for why everything exists.
Yeah.
You have to answer a question at the beginning. You have to pick an answer. And the question that you have to answer is very simple. It's only 6 words. Did the universe have a beginning? So how many possible answers are to that question?
2.
Just 2. Yes and no, right?
Yeah.
So it turns out that if you investigate the implications of answering yes, you violate physics in one way. If you investigate the implications of answering no, you violate physics in a different way. If you come at this without a supernatural creator, you have to pick yes or no. Those are your only two options. You violate physics in one way or the other. You don't get to deny a supernatural creator and embrace all the laws of physics at the same time, at least not to be consistent. So we can talk more about that if you're curious about digging down to the details. But
that's very interesting. Along those lines, one of the questions I had written down to ask you was, my understanding is that Einstein himself at one point in time believed the universe had no beginning. I believe somewhere around 1915 or so. And then he ended up changing his mind. Is this relevant to what you're talking about here?
For most of the 20th century, actually, the mainstream view was called the steady state model, which was that the universe had always been there. There had always been something.
Yeah.
The Big Bang actually didn't become the predominant view until the mid 60s.
Oh, interesting.
But I'm even stepping back from specific models. This is a more fundamental question. And I like doing it this way because how many people really know the ins and outs of the particular, scientific model and whatever obscure area we're talking about?
Yeah.
And just focus on big questions. Did the universe have a beginning? If the answer is yes, then the universe had a beginning. And if the universe is everything, which is what the word means, then everything had a beginning. If everything had a beginning, what was there before that beginning? Nothing, right?
Yeah.
Because if there was anything, then whatever began was no longer everything, thus was not actually the universe. So if the universe had a beginning, before the beginning, there had to be nothing. That means if you choose this option, this answer to the question, that something had to come from nothing. Now, does physics allow that to happen? Well, there's a very fundamental principle in physics called the conservation of mass energy, meaning the total amount of matter and energy in the universe never changes. You can convert one to the other, but you can't create anything from nothing. And if you ever take a physics class, you'll see this principle pop up in a lot of the various formulas and stuff that you apply.
Sure, this is thermodynamics.
Yes, right? This is sometimes called the first law of thermodynamics. Yes.
Yeah. So along those lines, I actually had Lawrence Krauss on my program at one point in time, and he wrote that book, A Universe from Nothing.
Right.
And yet he's supposed to be a very, very, and his credentials are like through the roof. So, what would that conversation look like if you brought this up to him? It was a lot of what he was saying was over my head. I was like, okay, explain to me how you get something from nothing, because I don't really get that.
Well, he's already had this conversation with many people because many people have asked him this.
Yeah.
And if you read the book before chapter 1, it's actually starting in the preface, he starts to explain that what he means by nothing is not what most people mean when they say nothing. When he says nothing, he's talking about empty space that happens to be permeated with fields and obeys laws of physics and contains energy and all the rest of it. Well, that's not really nothing anymore. Relativity says that space-time is actually something, even if it doesn't happen to contain particles, which is Dr. Krauss's sort of working definition of nothing. If there's no particles there, it's nothing. But even empty space, it can be warped and distorted by mass. It can flex and twist. It is something. You might hear the phrase the fabric of space-time, because that actually behaves that way. So space-time is something. Whether or not it has particles, it's still something there. So he's not actually saying how everything came from nothing according to how most people think of what nothing means.
Gotcha.
He doesn't even actually attempt to address that until late in the book. I think it's page 163. He starts saying about, well, okay, so this doesn't really say where space and time itself came from, but a quantum theory of gravity explains that. What is not said in the book, though, is that we don't actually have a quantum theory of gravity. This is a problem in physics for several decades now. It's famously difficult. No one has solved it yet. It's also, there's a further problem with that statement as well. To say that today's laws of physics permit something to happen, well, what is a law of physics? It's a pattern of behavior that we've observed that the universe obeys, and we capture it in a mathematical formula. If you're going to say that the laws of physics, you can't say that it came into existence with the universe and simultaneously being the cause or involved with the cause of the universe.
Gotcha.
Because a cause has to come before an effect. So if you're going to say, well, quantum gravity allowed the universe to come into existence, well, what context was quantum gravity existing in? There's still something further back, right?
Yeah. So he's just really, he's answering yes and no to the question all at the same time, trying to, like you said, have his cake and eat it too. But I've heard somebody say, well, look, you believe in the laws of the first law of thermodynamics, the conservation of energy and matter. But then all of a sudden you say God did it. And how does he make something come from nothing? You're violating the scientific laws by appealing to a supernatural creator. How would you respond to somebody who said that?
Well, he's outside of the universe. So a being outside of the universe can operate on the universe without violating the laws that universe operates according to.
Gotcha. So it's logical. It's not illogical like you have to do if you don't have that supernatural creator.
Right. And I'm arguing further that it's the only logical option left, because if you ask, did the universe have a beginning? We've already talked about yes, means something had to come from nothing, which physics doesn't allow. What about the other option? No. Does physics allow that? Well, now we're running into the second law of thermodynamics, which has a lot of implications. It's something we could have a whole conversation about, actually. But this is something we experience in our daily lives. Like coffee, for example, hot coffee gets colder over time, right? Cools off to room temperature.
Yeah.
So you can use coffee, and this is by the second law of thermodynamics that is doing this, by the way. So you can use coffee as a crude form of clock. If you walk into a room and there's a hot cup of coffee sitting there, how long has it been there? A long time or a short time?
Very good. A short time.
Short time. Could it have been there forever?
No. It would be cold.
It would have cooled off forever ago.
Yeah.
Right?
Yeah.
So if we look out in the universe, is there anything we see that hasn't cooled off yet? Stars.
Yeah, many things. Yeah.
The sun. If the universe were eternally old, everything that is currently hot would have cooled off eternally long ago.
Now, this was put forward. Yeah, go ahead.
Some people would argue now, like new stars can form. There's actually issues with that statement, but even granting that, star formation still requires energy, of which there's a finite amount available. If the universe were eternally old, that would have been consumed eternally long ago as well. So second law of thermodynamics tells us that trillions and trillions of years from now, if you wait long enough, everything that's hot today will have cooled off. No new stars can form. Everything that's radioactive will have decayed. The entire universe will be a few degrees above absolute zero. This is called the heat death, where everything is the same temperature. We have not reached that point yet. Therefore, the universe is not eternally old.
Yes. Yes. This is,
because if it were, it would have reached this eternally long ago.
It would already be cold. This is George Gamow, I believe. Is he the one that came up with this idea?
I'm not familiar with that. I'm familiar with other work he did. I don't know that he talked about this specifically.
Oh, okay.
This idea has been around for a while, so I'm not sure.
Gotcha. Okay. So along those same lines that you were talking about right there, I had a really good question that I wanted to ask you, and it just left my mind. Well, something I did want to talk to you about that's relevant to the planets and, what we started out with. By the way, if you're just tuning in, my guest today is Psarris, and his website is creationastronomy.com. He's got a fantastic DVD set that is well worth your time checking into, looking at what you aren't told about astronomy. And as well as he's written many articles that you can check out at creation.com, as well as Answers in Genesis and other places. So Spike, in your background, you've got a galaxy here. What is that? What is that galaxy right there? Is that our galaxy?
Messier 51.
Okay. So this is something I've had a question about for a long time. And I was curious to ask you about it. I've heard that the Nebular Hypothesis, if you follow it, which you're saying is faulty, that if you were to follow it, that the rotation of galaxies and planets should all be going in the same direction, but yet there are planets and galaxies that actually rotate in the opposite direction. Is that true? Is that a valid argument against the Nebular Hypothesis?
The Nebular Hypothesis specifically refers to the formation of the planets and moons in our solar system. Well, of our solar system itself, planets, moons, and other objects.
Gotcha.
So galaxy rotation is a different question. Our solar system exists within our galaxy, but the galaxy is much bigger than the solar system. So the nebula theory is talking about planets and moons coming out of a swirling cloud of gas, but galaxy rotation is a separate issue.
Okay. So does that pertain to I believe not all the planets rotate in the same direction. Is that correct?
Correct. Venus rotates retrograde, so backwards compared to the others.
And is that a problem for the Nebular Hypothesis?
It was not expected. There have been proposals for how that could have happened that way.
Okay.
A larger issue is Uranus, which rotates over on its side. Its axial tilt is more than 90 degrees. Whereas all the other planets spin like tops as they go around the sun, Uranus rolls along sideways like a ball.
Oh, interesting.
So that's something that it should not have formed that way, according to the Nebular Hypothesis.
And are there valid theories that would justify that difference?
The usual explanation is that a large impact or asteroid of some sort, something the size of the Earth, a very large object, hit Uranus early in its history and knocked it over. There's issues with that explanation, though. Uranus's orbit shows no sign of such an impact. Its orbit is almost perfectly circular. And it also has a system of satellites, of moons, that orbit its equator. And remember, its equator is almost perpendicular to the plane of the ecliptic. So trying to figure out how these moons formed in this impact scenario is a real problem. Had they formed before the impact, then they wouldn't be orbiting where they are today, because they'd be orbiting more within the plane of the ecliptic, more or less. They wouldn't have formed after the impact for various reasons, and forming them during the impact is challenging as well. So without getting into details, the moons cast doubt upon this explanation, but it's the only explanation available, so it's the one that's usually presented.
Okay, gotcha. Now, as far as the Big Bang is concerned, is there a problem with a creationist believing in the Big Bang? One of the things that I believe Edwin Hubble, postulated the expansion of the universe based on what he was seeing. I believe it's with the redshift, with the colors. Correct me if I'm wrong, but is that expansion, is that a problem for creationists to agree with a Big Bang, or is there a way to coherently meld what the Bible teaches in Genesis with that hypothesis?
The redshifts that Hubble is known for investigating are consistent with the Big Bang model, but they don't demand the Big Bang model.
Okay.
There's other ways to look at that as well. So when you say the Big Bang as well, you can mean that in a generic sense, where there was a point from which things are expanding, or you can be more specific. The consensus model among secular cosmologists includes not only that expansion, but also cosmic inflation, dark energy, and some other things that represents the Big Bang model today. So saying that redshifts are evidence of expansion, that's one way to interpret them. Possibly that's an artifact of God having expanded the heavens early in cosmic history. The Bible says multiple places that the Lord stretched out the heavens. Is that poetry? Maybe it's meant literally. If that's the case, maybe that's what these redshifts represent. However, this is not to say that we should be endorsing the secular full-on Big Bang model, because that has a lot of assumptions built into it, some of which aren't consistent, I'd say, with a theistic outlook necessarily. And there's some other conclusions that a Big Bang cosmologist is forced to draw as a result of his approach or her approach that aren't necessarily required just on a strict evidential basis either. That was probably too long of an answer. I'm sorry.
No, that's okay. I'm actually really curious about this because one of the things, I don't know a lot about this, but I've heard about it. And I was told that dark energy, dark matter are something that are required they're basically filler for holes in the Big Bang theory, the scientific theory. And you have to have dark energy and dark matter to explain how this would all work, but that it wasn't necessary in a creationist model. Is that true, or what's going on there with dark energy and dark matter?
Dark matter and dark energy, the names are unfortunate because the word dark appearing in both makes it sound like they're linked, but they're actually very separate things.
Okay.
Dark matter refers to evidence for mass where we don't see any mass. So, for example, galaxies are rotating in such a way that the stars on the outer edge are orbiting too quickly for that galaxy to be stable over long periods of time. Perhaps there hasn't been long periods of time, is one way to look at it. But assuming that they are stable, why don't we? So one way to explain those rotation curves is to postulate that there's a halo of matter further out, and the gravitational impact of that is what's causing the curves that we see. The issue is that we don't see the mass there. So perhaps that mass is in things that are very difficult to see, like brown dwarfs, for example, will be, at that distance, we wouldn't be able to see them. They don't radiate much energy. Others say that that's insufficient. So now the preferred explanation is that there's a lot of particles out there that don't interact with normal matter other than through gravity. So that's dark matter.
So dark it's just energy. Okay, I see what you're saying. Okay. Yeah. Go ahead.
So dark matter is an attempt to explain actual observations.
It's basically. So would you say that's a? I spoke with Jason Lyle, and he said that that's what he would call a rescuing device. Something that I don't know if he would call that a rescuing device, but he says it's something that you throw in to prop up your theory, because without it, you have no way to explain it. Is that true or no? In this,
I would say that's
case?
True of dark energy.
Okay.
Dark matter is more based on observations than dark energy is.
Okay.
There are some creationist astronomers who are friendly, for lack of a better word, to the idea that there's a new form of matter causing these observations that we see.
Okay. Where do you stand on that? What's your perspective?
I'm less interested in the exotic particle interpretation as I am in the ordinary matter that's too difficult to observe.
Okay.
But I'm open either way, really.
Okay. You're just
that's dark matter
at this point. Gotcha.
Dark energy is, though, in answer to your original question, is required by the Big Bang model. That's an attempt to interpret observations of cosmic expansion over large scales, where the expansion early in the universe's history, according to a Big Bang interpretation now, doesn't match what the Big Bang model said. So they had to add dark energy to the Big Bang model, which is a anti-gravity energy that permeates space and continually creates more of itself as the universe expands and gets bigger. And as it creates more of itself, the outward push is getting stronger. So over billions of years, the universe is expanding faster and faster.
And so if I understand that correctly, the problem with that from a physics perspective is that we have no reason to think there's enough energy, unless it's, quote, dark energy, that the rate of expansion would be speeding up. It shouldn't be speeding up. It should be slowing down. Is that
correct? Yeah, gravity should be slowing down the expansion, but over a large enough time scale, as interpreted by the Big Bang way of looking at things, it's expanding faster and faster. So we've got to have a rescue device to figure out what that is. And right now that's dark energy, even though there's no actual evidence for that. Other than this interpretation that's demanded by the Big Bang model, yes.
Gotcha. Okay. You know what? I remembered my previous question too. We're hopping around a lot here, but
that's fine.
I like the conversation. It's very interesting to me. So the question I had, I got into a discussion with somebody about a non-believer about star formation, and they were saying that stars can form, and so the argument was that the universe is still producing stars, because we were talking about I'm blanking a little bit, but from my perspective as a biblical creationist, my perspective was that the stars, we don't see stars forming anymore, was my understanding. But he corrected me and said, no, there are stars forming. We see stars forming. Is that true?
We see a single star forming would be far too long for us to observe, because it would take place over a long period of time, and we haven't been looking that long. Mm-hmm. We do see different galaxies and different places within those galaxies where different snapshots, for lack of a better word, appear to be in different stages of star formation. In other words, we see places that are consistent with our ideas about how stars would form. So, but the important question isn't really, are stars forming today? The important question is, how did they form in the very beginning of time? That's too melodramatic, but how did the first generation of stars form? Because the mechanisms for star formation today typically invoke things like a supernova explosion compressing a cloud of gas, and that kickstarts the compression, and then stars can form. Or a supernova goes off and blows a bunch of particles and dust grains into this other cloud, which cools it down, drops the temperature, reduces pressure, and then stars can form. Most of the mechanisms for star formation invoke things like a supernova explosion to kickstart the process. But a supernova explosion is what? It's an exploding star.
Yeah.
So most of the mechanisms that we see for star formation need stars to exist before new ones can be made. The question is, where did the first generation come from? That's where the problem is.
Yeah. Which came first, the chicken or the egg?
Something like that. There's also an issue too, in that the first generation of stars could have only consisted of the matter that the Big Bang would have produced, according to their interpretation. So that's hydrogen and helium and maybe a little bit of lithium.
So
we don't see stars with that composition.
Gotcha. Is that in any way an argument for biblical creation? Would you say that that's a useful argument for arguing for biblical creation, or is that not something that you would use as an argument?
I talk about it.
Okay.
Yeah, it's not specific enough to talk about the Bible itself.
Yeah,
but it is to show that the conventional way of talking about things has problems.
Okay. Also, is it true? I was looking on a website and it said open letter on cosmology published by eLearner, basically that a lot of secular scientists are complaining that the Big Bang model isn't sufficient. Like an atheistic Big Bang model without a supernatural creator isn't sufficient. Is that something that's expanding beyond creationist circles? Is that something other physicists and astronomers agree that it's not sufficient, or is that just mainly Christians that are arguing that?
I think you're talking about Eric Lerner, and he represents a group called plasma cosmologists, who are arguing for an eternal universe rather than a Big Bang which requires a beginning.
So he's not arguing for something secular that we would agree with either, but
correct.
Yeah. But he's claiming that the Big Bang isn't sufficient. Is it true among secular cosmologists that they have generally problems with the Big Bang, that many of them are saying, no, this isn't a workable model, or is that something they're holding on to because there's no alternative other than a supernatural creator?
I think you'd find it very difficult to find any of the mainstream academics who are working in this field who question the overall idea of the Big Bang.
Okay.
You will find disagreement about different facets of it, like whether cosmic inflation happened or not. Some of the people who initially developed that idea have since turned their backs on it because of some of the ways that's developed. So there's discussion about parts of the model. I'm not aware that anybody is questioning the overall idea because they don't really have an alternative to suggest at this point.
Gotcha.
So
okay.
If you compare the Big Bang model today of the model that first took precedence in the mid 60s when it first became popular, the model today is very different than it was back then. There's been modifications slapped on. If you could be pejorative and call them Band-Aids.
Yeah. As
more problems have been discovered, we'll patch this. Oh, wait, there's another problem, patch that. And we'll add inflation and we'll add this and we'll add dark energy. If you look at this of the history of science and the structure of scientific revolutions, referring to the book by Thomas Kuhn, who talked about this, scientific models usually don't go gradually. When something becomes mainstream, everybody thinks in those terms. As more problems are discovered, they add patch and patch and patch and patch and patch. Eventually, the edifice gets so creaky and unstable that somebody comes in, usually a young person who hasn't written books and papers about the old model and thus doesn't have anything to lose.
Yeah.
And says, wait a minute, here's a whole new way of looking at things. And if that's successful, then usually sometimes in a short time, sometimes a bit longer, but the old model will be swept away in a fairly rapid fashion. I don't know. I'm not saying that will happen with the Big Bang because there's no alternative been proposed yet. I'd say it's ripe for it. There's been an accumulation of problems that from an outside perspective said, does this still seem like a good model to you if you're not already committed to this way of thinking?
Interesting. Okay. So from your perspective, when you're looking at our solar system, you're looking at the planets that are out there, what would you say is the most compelling argument for God and supernatural creation and biblical creation? Is there something that for you is by far the most compelling evidence, or is it just a whole bunch of evidence is stacked one on top of another that eventually it's just the conclusion is overwhelming? What's your perspective on that?
There's a lot of evidence for youth in the objects, and you can come at them from a couple of different perspectives. Magnetic fields, for example, the Earth has a magnetic field. If you use a compass, that's how that works. Ask the question, where does the magnetic field come from? Well, there's a couple of possible ways that the Earth could have a magnetic field today. One is that it had a magnetic field when it formed. So primordial, a remnant field is called. The issue with that, though, is that can't last for long periods of time. That will decay over time. So if you believe that the Earth is 4.5 billion years old, then that can't be the explanation. The only explanation that's consistent with billions of years is called the dynamo theory, which is the idea that the Earth's core is fluid. The fluid motions within it, moving through the magnetic field, induces electrical currents, which produces the magnetic field, which induces electrical currents, and it's a self-sustaining thing. The problem is that idea has a lot of challenges. That system will also lose energy over time. Your only source of energy in a model to keep it sustaining is heat from radioactive decay. And raw heat is not a very efficient way of accomplishing mechanical work. So people have been working on a dynamo theory for the origin of the Earth's magnetic field for a long period of time and hasn't been successful. Furthermore, the Earth's magnetic field is decaying measurably. It loses half its energy about every 1,400 years, give or take. So it's consistent with a primordial field from its creation recently that is now winding down. It's inconsistent with a field that's been self-sustaining for billions of years. Furthermore, there's no theoretical way to get it to last for billions of years. When we look at other objects in the solar system, we see similar things. Mercury, for example, is a tiny little planet, smaller than some of the moons in the solar system. It has a magnetic field. This was a real surprise to secular scientists because Mercury is so small, it should have cooled off and frozen solid billions of years ago because small things cool off faster than large things. So if Mercury is frozen solid, then its core can't have liquid currents within it, which means it can't have a magnetic field over billions of years, but it does have one.
Yeah.
Furthermore, the messenger mission found, comparing results to the previous Mariner 10 mission, Mercury's magnetic field is decaying too. Something like 7% over the 30-odd years between those two missions. Again, this field looks very young, not something that's been there for billions of years. Ganymede, moon of Jupiter, similar logic. Should have frozen solid, cooled off billions of years ago, has a magnetic field. Saturn has a magnetic field. Now, the issue here isn't that it should have frozen solid because it's big enough for that's not the case, but its magnetic field is aligned with the spin axis of the planet, which the dynamo theory says isn't possible. So
Gosh.
The fact that it has a magnetic field, again, it could be a young field left over from its formation, but that has to be very recent past, or it has to be from a dynamo, but it can't be from a dynamo, so the billions of years idea doesn't work. Planet Uranus, its magnetic field, it was a surprise too, because Uranus doesn't radiate heat out into space. It apparently doesn't have the source of internal heat. Well, with no heat, you don't get the currents in the core coming up, so you don't get the dynamo, so you don't get to have a field for billions of years. Therefore, it shouldn't have one, but it does.
Wow.
Neptune's field. Now, Neptune has enough energy to produce a field, but it is a different problem. Its field is offset from the center of the planet. But the dynamo theory says it has to go through the center of the planet, but it's not. Uranus also has that problem, by the way. So this is a more technical issue, and it's kind of obscure because who knows about magnetic fields of planets.
Yeah.
But when you understand the implications of this, if these objects were young, none of this is a problem. These could be primordial fields left over from their recent formation that are now winding down today. It's consistent with the observations. The billions of years requires dynamos, which doesn't match these observations.
Oh, that's amazing. That's a lot of things too. That's a lot of different issues that you're trying to justify. A question I have too is I've heard, and I don't know if this is a legitimate argument or not. I've heard that the Earth's rotation is slowing down. Is that true that the rotation of the Earth is slowing down?
Yes, it is.
And so the argument was, well, this is an argument for a recent creation, because if you go backwards in time and it's speeding up because it's slowing down, eventually you would get to a point where it was rotating so fast that life wouldn't be able to survive on the planet. Is that actually a legitimate argument?
I don't think so.
Okay.
It's tied into, among other things, the recession of the moon from the Earth. The moon is slowly moving away from the Earth. And so the reason the Earth is slowing down is because that energy is being transferred to the moon and the moon is moving away.
Okay.
Looking backwards in time, the moon would have been touching the Earth because it's moving away today. So backwards in time would have been closer, about 1.5 billion years ago. Now, nobody thinks it actually did that. So this would be an argument for the Earth-Moon system being younger than 1.5 billion years.
Okay.
That's not an argument for recent creation. It's not precise enough of an argument. It also makes assumptions about how the Earth's continents were arranged in the past and whatever. So it's not specific enough to draw hard conclusions, but it is worth mentioning in that if you just look at what's going on today and extend it backwards in the past in a straightforward fashion, you do see things that are inconsistent with the 4+ billion years way of looking at things.
Because the Earth-Moon system is how old, according to secular astronomy?
The moon would be there roughly 4 billion years, a little bit more, depending on when this giant impact was.
And based
There's
on
different ideas on this, but
gotcha. And based on what we're seeing, as far as its recession, that just couldn't be possible. It couldn't be that old.
Well, to say it wouldn't be possible is to imply that there's no possible explanations for it. A secular scientist would propose an explanation that the Earth's continents used to be arranged differently in the past, and so the friction between the tidal bulge that the moon is producing, et cetera, et cetera. They're proposing that things used to be different in the past, therefore the rate of recession would have been different in the past. But that's not based on current observations. Now we're getting into the larger question of when do you leave the idea of science and get more into storytelling?
Gotcha. And is that how you would go ahead?
Oh, go ahead.
I was going to say, and is that how you would respond to somebody, you know, who keeps bringing up hypotheticals after hypothetical after hypothetical? It's kind of like, well, it could have happened. I mean, how do you talk to somebody about when it's constantly, well, it could have happened? What do you say in that scenario?
Well, it's a good question. It's a worldview issue because all of us on all sides of this debate, we're used to thinking in certain ways. Mm-hmm. Sometimes people will switch sides like I did, but that's not an easy process. You know, it's very uncomfortable to retrain to, reshift your thinking. We see that the storytelling angle come up perhaps more in astronomy than other things because to solve certain other problems in the solar system now, there's models that say there used to be 5 giant gas and ice planets. Some even say 6. Well, we see Jupiter, Saturn, Uranus, and Neptune. But to explain away certain problems, people are creating simulations with other giant planets that did various things and then left.
Oh, wow.
How do you refute that model?
Yeah, you're getting into like real, just crazy hypotheticals where it's almost like anything goes.
Right. If you're allowed to invoke things for which there's no evidence today, then, like you said, anything goes.
It's just not hard science anymore.
That's what I would argue.
Gotcha. Okay.
I would also say looking at current observations, there's other challenges that these things aren't even addressing. Like we talked about magnetic fields already. Another issue is geological activity. So the Earth is geologically active because there's plate tectonics, and a lot of this is driven by internal heat, which is produced by radioactive decay. So with the Earth, okay, fine, that's why we're geologically active. Other objects, though, don't necessarily have that as a possible source, and especially if they're small, they should have cooled off a long time ago and shouldn't be geologically active anymore because they would have lost their heat. The moon, for example, should have cooled off well over 1 billion years ago, if it were really over 4 billion years old.
Yeah.
Shouldn't be geologically active anymore. Now there's evidence that it is geologically active. Going back to the 1500s, there's been eyewitness accounts of people seeing flashes and temporary glows of light on the moon's surface. Possible explanations are the moon is releasing gas from volcanic vents. But
it could also be aliens.
I didn't want to go there. But no one really took this all that seriously because if you think the moon's billions of years old and it's an observation that can't be repeated because it's a very short event. But then the Apollo astronauts brought seismometers to the moon, left them behind, and they operated for a while. And they recorded a whole bunch of moonquakes. And some of these moonquakes specifically are associated with what we perceive as faults on the moon's surface. These are apparently tectonic faults, which means this is tectonic activity, which means the moon is still geologically active. Elsewhere in the solar system, the surface of Venus was, even from a secular perspective, looks very young and fresh. There's no evidence of chemical weathering, of billions of years of erosion or whatever. It looks like the whole planet was resurfaced by volcanic activity not that long ago. Well, Venus doesn't have plate tectonics, though. What's driving this geological activity? No one's really sure.
So I'm sorry, go ahead.
I say further out in the solar system, we have Io, or Io, depending on how you pronounce it, one of Jupiter's moons. It's the most volcanically active body in the solar system. Tiny little moon, hundreds of volcanoes on its surface. Some of them are blasting material into space 180 miles, very, very dramatic. Where is the energy for this activity coming from? Well, some of it's coming from tidal flexing, where it's caught in a gravitational tug of war between Jupiter and the other moons, and so it's being squeezed and flexed. It is receiving energy from that, yes, but that's not enough to explain what we see. Furthermore, if Io were really billions of years old, 4.5 billion years old, there's enough material coming out of the volcanoes for it to have recycled the entire moon through its own volcanoes over 30 times.
Wow.
Is that a reasonable thing to believe? And also, by the way, the volcanoes aren't distributed in the patterns we would expect if the tidal flexing was producing all of this. I'm arguing it's more reasonable to say this is primordial heat left over from a recent creation that's consistent with this.
Yeah.
The billions of years has problems.
So that's what I was going to ask you is, you're just laying down, issue after issue after issue. And so obviously this is the reason that you've come to the conclusion, or that you continue to adhere to the idea that these are all recently established. And so if in that regard, is there any big problems that you see from your perspective, from the biblical creationist perspective? Is because you've laid out all these problems with secular astronomy and secular ages. So are there problems for the recent creation perspective that somebody else might bring up that would say, yeah, well, sure, we have our problems, but so do you. And so here's yours. Do you see any problems with the recent creation perspective?
Well, one of the things that's often brought up is radiometric dating. We have rocks, so the moon rocks that were brought back, you date them and they produce very long ages, not 6,000 years, billions of years. I know on your show you've had, I believe, Dr. John Baumgartner, Dr. Jay Weil, and some other people who have talked about this. Yeah. Radiometric dating methods are based on assumptions. We can take very precise measurements of the samples today, but to convert that into an age measurement into the past requires certain assumptions. And if the assumptions aren't valid, then the age conclusion isn't valid either. This is something that a lot of creationists are talking about. I'd like to see more work done on it myself. Of course, there's not all that many people active in the creation movement who can do this sort of thing. Sure. So would you say that's the biggest issue in your mind? Probably. We have answers for it, but the answers aren't formalized, maybe might be the best word for it. There's different ideas, many of which look very promising, but through a lack of people, really. Yeah. And funding, of course. Yeah. You're not going to get $1 million grants from the government to prove that the moon is not billions of years old. Right. So when you say that in regards to radiocarbon dating or any type of radioactive dating, when you say it's not formalized, you mean that we haven't been able to establish exactly why the ages are showing up as old as they are, and we haven't been able to give a consistent response to that? Is that what you're saying? A very scientifically evidential based response? I'll say a couple of things. Carbon dating is actually our friend in this. Yeah. Because a lot of things that are supposed to be old still have measurable carbon-14 in them, which is impossible if they were more than a few tens of thousands of years old. Yeah. So from that perspective, those dates are on our side. The methods that produce other ages like millions and billions of years, we can easily show that samples that are known to be young, when tested by these methods, will still produce millions and billions of years ages. Even though we know this volcano erupted in 18 whatever, so that's when the clock started for this particular dating method, but it says millions of years ago. Yeah. Well, what we don't have formalized yet is, number one, a comprehensive listing of all these dating methods, because there's multiple, and a in-depth, detailed explanation of why they're producing these wrong ages. We know that they are, but there's several different reasons why they could be. Were the rates of radioactive decay higher in the past? There is some evidence for that. Why would that have happened? Well, now you're going to get into nuclear physics, which only a handful of people are really qualified to talk about. And there's been some work on that from our side, but not really detailed enough to show why these methods produce wrong answers. We have lots of examples of them producing wrong answers. We're not quite sure why that's the case, though.
Oh, that's really interesting, huh? Wow, that's something to pray about right there. Got to get some more nuclear physicists in here.
Right.
That's great. Well, for those of you listening, my guest today is Spike Psarris, and he is an astronomer and has a lot of experience in the U.S. naval. I'm sorry, not naval. U.S. Was it NASA, Spike?
No, NASA is the civilian side of the space program. That's the fun, friendly, let's go explore side. I was in the dark, nefarious, let's exploit space for military purposes.
Okay. Where all the conspiracy theories come from. And his website is creationastronomy.com. You can check him out there. He's got an awesome DVD set, well worth looking at. And then a bunch of different articles that he's written. Obviously, he's incredibly well informed and knowledgeable about this subject material. So please check out his stuff. And Spike, I just want to say thanks a lot for being on the program. I think, man, you are a wealth of knowledge. So I appreciate everything you're doing. Yeah, absolutely.
My privilege.
Yeah. So hopefully we can maybe do it again sometime in the future and
Sure.
Talk more about this. So if my website, of course, is educateforlife.org. You can check it out, and all kinds of resources on there for you. We actually have a basics with the problems of secular astronomy on there, as well as numerous other classes on world religions, on how we know the Bible's God's word, and then even cultural issues. How do we respond to our friends and family in a winsome way, in a loving way, but also in a truth-filled way regarding the current cultural issues that are going back and forth all over the place. So educateforlife.org, that's my website. We'll be here again in 2 weeks, and we'll be talking about the importance of making sure your kids are prepared for life after high school, as they have to deal with all these different attacks on Christianity in the Bible. So I hope you'll join us next time. Thanks a lot, and you guys have a fantastic evening.